I'll do a short video to finish up 17 through 21 before we get into the solving equations video. So with these, it's just kind of a little bit of a mixture of everything to see if you're okay with everything. So with this one, we have a fifth root. Again, I would always look to see if you can simplify something first. I'd probably do that. So I would look at this and say, all right, I'm going to leave the x to the 10th in the numerator. Because this is a y to the negative second, I'm going to take those two y's, y squared, and bring it down to the denominator. So if I had y to the third, and I bring those two y's down here, I'm going to have a y to the fifth. And now when I simplify, these are perfect fifths, because 10 divided by 5 is 2. Remember, this is what we're doing when we have exponents. We're taking the exponent divided by the root. And here we have 5 divided by 5. They're both exponents. I get y to the first. Okay, so remember, this doesn't work if there's a coefficient in front of here when you take a fifth root. But when you're using exponents, you're just putting in an exponential, 10 over 5 and 5 over 5. All right, so let's do 18. 18 is a number. And so when I look at 18, I'm thinking of a number that is a perfect cube. So now I'm thinking of our list of perfect cubes. 2 to the third is 8. 3 to the third is 27. 4 to the third is 64. So this is our list of perfect cubes, and I want one that is a factor of 108. And so I believe it's going to be 8. You can use your calculator. Just take 104 divided by 8, 104 divided by 27 until you find the one that works. And when you break it up into 8 and you do 104 divided by 8, you should be left with 13. So the cubed root of 8 is 2. The reason we picked this 8 is now I can take the cubed root of 8, and I'm left with 2 then times the cubed root of 13. So with a number, you have to think of this list of perfect cubes. When you're dealing with exponents, remember, they have to be a multiple of that root so that they simplify. All right, let's look at 19. 19 looks like one where we want to try to add like terms, but you can tell these are not like terms as is, so we need to simplify. So when I look at this one, square root of 9 comes out nicely to 3. W to the fifth is not a perfect square root because it's not divisible by 2. So I'm going to break it up into square root of w to the fourth and square root of w to the first. Because w to the fourth, when I put that in exponential, 4 divided by 2, I get w squared. Same with this over here. I have a minus w times. The square root of w to the third is not a perfect square, so I'm going to break it up into the square root of w squared and the square root of w. So I can simplify that now because 2 divided by 2 is 1. All right, so let's simplify. I have my 3 from the square root of 9. W to the fourth, 4 divided by 2 is w squared, minus, here I take the square root of w squared, 2 divided by 2 is 1, so this becomes w to the first, so w times w is w squared, and you still have that square root of w. Alright, if I'm going to be able to add these together, remember, these have to be like terms, so it might help to even circle it. This has to be exactly the same as that, and they are. So if I have 3 of those terms minus 1 of those terms, I have 2 of those terms when I'm adding them together, or subtracting them in this case. Okay, so they weren't like terms as is. We had to simplify by breaking them up into perfect squares. Once you get to this point, if these are exactly the same, now I can add them together or subtract them. All right, number 20 goes back to some fractional exponents, and again, before you get started, I would simplify. 6 divided by 3, x divided by x to the 1/2, and y to the 3/4 divided by y to the 1/2. So 6 divided by 3 is 2. X to the first divided by x to the 1/2. Property says I keep the base. I have to subtract 1 minus 1/2. And for the y's, I have y to the 3/4 divided by y to the 1/2. I keep the base. I subtract the exponents. 3/4 minus 1/2, which is 2/4, is 1/4. The directions do not say we have to put anything back into radical form or anything else. We just leave our answer like that. All right, and then 21, these are not perfect cubes, so we have to break them up into perfect cubes. So the cubed root of 16, again, you're thinking the perfect cubes. 2 to the third is 8, 3 to the third is 27, and the one that's going to work right away, I know, is 8. So I break up the cubed root of 16 into the cubed root of 8 that I can simplify, and the cubed root of 2. All right, then we get to the exponents, and again, in order to be perfect cubes, these have to be multiples of the root, multiples of 3. So I break up the a to the 7th into the cubed root of a to the 6th, with an a to the 1st left over. B to the 5th, I'm going to break up into b to the 3rd, with a b squared left over. And c to the 9th is a perfect cube, because it is divisible by 3. So that's a perfect cube. That is a perfect cube. That is a perfect cube. So anything that I've circled, I can simplify. Cubed root of 8 is 2. A to the 6th, the cubed root of that would be a to the 2nd, 6 divided by 3. B to the 1st, because that's 3 divided by 3. And c to the 3rd, 9 divided by 3. What I haven't got circled has to stay under the cubed root, so I have a 2, I have an a, and a b squared. Before you're done, you do need to make sure everything under here, there's no more perfect cubes that go in there, so all of these exponents should be smaller than 3, and they are, so we're good there. All right, so that kind of finishes up those. My next video, I'll do the equations.